Hello everyone, welcome to Engineering Archives. Let's now look at our practice problem number 5. So this problem says, the chisel exerts a force of 20 pounds on the wood dowel rod. I don't know how to pronounce that. Dowel rod, which is turning in a, I don't know how to pronounce that either. Resolve this force into components acting along the N and T axes and along the X and Y axes. Okay, so let's start with the X and Y axes since they are the conventional perpendicular axes. So the X and Y axes look like this, and our force is acting somewhat like this. So in order to resolve this force into the X and Y components, we will need to get the angle between the force and one of the axes. Right? So let's look at the diagram. So here we can see that this is the x-axis, and the force makes this angle with the x-axis. Now we know that this angle between the x and the y-axis should be 90 degrees. And if this angle should be 90 degrees, that means that this smaller angle here should be 30 degrees, because 30 plus 60 should make 90. So we know that this smaller angle right here is 30 degrees. And then we know that this angle right here between this N line and our 20-pound force is 45. So this smaller angle between the x-axis and the 20-pound force should be 15 degrees. So we know that theta equals to 15 degrees. Now that we have the value for theta, we can simply find the components by applying the sine and cos identities on the 20-pound force. And notice that this time we are not going with a vector triangle, since the set of axes that they have given us is perpendicular. And because it is perpendicular, it is easier for us, and we can simply apply the sine and cos identities and simply get the components. So for the y component, we'll simply do 20-pound force multiplied by sine of 15 degrees, and this should give us 20 sine of 15 should give us 5.2 pounds. While for the x component, we'll simply do 20 cos of 15, and this would simply give us 19.3 pounds. Alright, now let's do the N and T axes. These axes are called the normal and the tangential axes. And we'll deal more with these axes in the dynamics course. This is the N axis, this is the T axis. 20-pound force is acting something like this, and they have given us the angle between the 20-pound force and the N axis, and this angle is 45 degrees. So you might notice that there is some discrepancy between this value and this diagram, but you can just ignore that because this diagram is only for illustration. So let's draw this force in this quadrant. This angle is 45. Right. So to get the N component, we'll simply use the cos identity, which is 20 cos of 45. That should give us 14.14 pounds. And to get the T component, we'll simply do 20 sine of 45, and this should give us also 14.14 pounds. So this was a simple and easy way to deal with a set of axes that are perpendicular to each other. Thank you very much. See you in the next video.